Find the LCM of 18, 24, and 30 using the prime factorization method. Please go through the below steps so that you do not make any mistakes. Step 1. Find the prime factorization of each given integer individually. Let us find the prime factorization of 18. Start dividing 18 by the smallest prime 2. Since 2 divides 18 exactly, we get 9. Again, start dividing 9 by the smallest prime 2. Since 2 does not divide 9 exactly, move to the next smallest prime 3. Since 3 divides 9 exactly, we get 3. Observe, 3 is a prime number. So, divide it by itself. Since 3 divides 3 exactly, we get 1. Stop here since 1 is reached. Finally, collect all the prime divisors. In this case, they are 2, 3, and 3. So, prime factorization of 18 is 2 multiplied by 3 multiplied by 3. Got it? Similarly, prime factorization of 24 is 2 multiplied by 2 multiplied by 2 multiplied by 3. Also, prime factorization of 30 is 2 multiplied by 3 multiplied by 5. Got it? Step 2. Identify all the distinct prime factors among the given integers. In this case, the distinct prime factors are 2, 3, and 5. Step 3. Identify the maximum occurrences for each distinct prime factor. Observe, 2 occurs in the prime factorizations of 18, 24, and 30. But it occurs more times in the prime factorization of 24. So, we take 2 multiplied by 2 multiplied by 2 as its maximum occurrences. Similarly, 3 occurs in the prime factorizations of 18, 24, and 30. But it occurs more times in the prime factorization of 18. So, we consider 3 multiplied by 3 as its maximum occurrences. But 5 occurs only in the prime factorization of 30. So, we consider 5 as its maximum occurrences. Step 4. Multiply all the prime factors using their maximum occurrences. Therefore, LCM of 18, 24 and 30 is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 gives you 360. Got it? Thank you for watching. For a deeper understanding of HCF and LCM, please subscribe and watch the playlists below from beginning to end.